One of the best features of Java is its garbage collection. As a Java programmer, you almost never need to concern yourself with memory management. It's handled for you. To show you what I mean, let's take a look at the Text2 class from the previous lesson. Inside a method, whenever you declare a reference, as is done here with a rectangle, the space for it is allocated locally and only exists while the method is being executed. Once the method returns to its caller, the reference is deleted and the memory it used is available for other parts of the program. Objects, on the other hand, are allocated space from the free pool of memory, and that memory will remain dedicated to the object only as long as there is at least one reference holding its address. Once no reference can be found to an object, the system reclaims it. Now, as this program runs, the paint method is called again and again to draw the string. Each time it's called, the getBounds method is called, and it creates a new rectangle object. There is no code to delete the rectangle object because Java handles that for us automatically. When the paint method completes its task, the reference name rect, holding the address of the rectangle object, is returned to the system. Java notices that fact, and notices the fact there is no longer a reference anywhere to the rectangle object, so it reclaims the object and recycles the memory that it was using. This process is known as garbage collection. You can create all the new objects that you want in your program, and Java will come along behind you and clean them up. All you have to do is forget about an object, and it automatically returns to the system. This makes it difficult to write a Java program that accidentally expands and hogs computer memory. A bug like this is known as a memory leak and is quite common in other languages that use dynamic memory allocation, such as C and C++. Garbage collection is one of the most attractive features of Java. It makes life very easy when you don't have to clean up behind yourself. All you have to do is forget about something and it's automatically reclaimed and recycled. The process of garbage collection is recursive. That is, if you no longer have a reference to object A, it is reclaimed by the system. If object A, in turn, contained a reference to object B, then it is also reclaimed. This process continues until every bit of memory that you can no longer access is returned to the system and is available for use by the next new statement. Now, all of this takes place while your program is running, so you'll see discussions on the efficiency of garbage collection. You may also come across discussions comparing one garbage collection algorithm to another. The garbage collection routines in the Java virtual machine today are much faster and more efficient than the ones that were in there when Java was first released. In this example, the paint method is called every time the window is updated, and three objects are created. They are the rectangle, the string, and the font metrics object. When the paint method finishes, the references are all returned to the system, so the objects are all recycled. But all this happens very fast. The memory allocation and reclamation routines are fast enough that you can ignore them. It's a very rare situation that requires that you do something to reduce the amount of garbage collection. Generally, this sort of problem only arises in time-sensitive real-time processing, and even then it's considered better policy to make the thing work first, then come back and speed it up.